Welcome back, student. In this chapter 1.2, we will learn about resolution of forces. At the end of lesson, students should be able to describe resolution of forces and solve problems involving resultant force and resolution of forces. So first, let's see the definition to the resolution of forces. What is resolution forces? Resolution forces is the process of resolving a force into two components without changing its effect on the body. Basically, this is the illusion on how to resolve or divide forces to two components, Fx and Fy. From this figure, a box is being pulled by in the right direction, positive on a surface. Since there is a force, there is also a frictional force unless being mentioned that the surface is a frictionless surface. There are also normal force N and weight W act on the object on Fy. Now let's move on to the next slide. Here are two steps to determine resolution of forces. The first steps you need to do is to draw horizontal and vertical components Fx and Fy on the objects, and then label F according to the direction of F given in the information or question. Second step is to calculate magnitude of both components, Fx and Fy, using this formula. From this slide, you can see there are four quadrants. There are two rules in determining direction of F when you draw and resolve F into two components, which is axis X and axis Y. As you already know, negative is left direction and downward, while positive indicate that the direction is right and upward. The value of F is positive if it is in right and upward direction. But if the direction of F is leftward and downward, then the value of F is negative. Next slide is an example of how to find F using trigonometric function Sohkah Toa. First, let's see the first triangle ACD in this figure. To find Fx, you need to use cos theta. By using trigonometric, theta can be found using adjacent over hypothesis or Fx over F. After you do the mathematical calculation, then you will get the value for the Fx component. Then let's see the second example of the triangle ABC from this figure. Same as above, to find Fy component, you need to use and do the calculation using trigonometric function formula. Don't forget to include the unit Newton for the Fx and Fy after finding out the value for Fx and Fy. Okay student, before we continue our lesson on the problem involving resultant force and resolution of force, I need you guys to prepare a pen, calculator and of course papers. Okay, ready? Let's go! In this subtopic, you need to know how to find resolution of force and resultant of force because both of these are different. For the resolution of force, we can divide a force into two components which are horizontal and vertical component. For the resultant of force, it can be described as the total amount of force acting on the object. Okay, now to make sure you can do the calculation, you can use this 3I1S formula. First, identify the problem. Second, identify the information. Third, identify formula, and lastly, solve it. Let's try this question together. Figure 1 shows a man mopping the floor. Calculate the magnitude of horizontal component of pushing force, vertical component of pushing force. Okay, we will make it step by step. First, identify the problem. In this question, we need magnitude of horizontal component of pushing force and magnitude of vertical component of pushing force. From the question, we know the pushing force F equal to 34 Newton and angle equal to 65 degree. Now, for the third step, we need to know the suitable formula. Remember, when the theta were on the plane, so it will be cos theta. So, the magnitude of horizontal component of pushing force is Fx equal to negative F cos 65 degree, and for the vertical, Fy equal to negative F sin 65 degree. For the last step, you can substitute the values and solve it. Remember, you need to give the answer with the correct unit. The answer for Fx is negative 14.37 N and Fy equal to negative 30.81 N. Okay, now student, let's read the next question. Figure 2 shows a box is pulled by a rope at an angle of 45 degrees from a smooth floor with a force of 6 Newton. If the mass of the box is 5 kg, calculate the acceleration of the box. I will give you 5 minutes to answer this question, and please use the 3I1S formula to find the answer. So now let's discuss the answer. First step, we identify the problem first. The question asks the acceleration of the box. However, we need to do the resolution of the force acting on the box. Second step, come out the information given from the question. Pull force F equal to 6 Newton, angle equal to 45 degrees, mass of box equal to 5 kg. And then you need to use the suitable formula. For the magnitude of force in the horizontal component, we use the formula Fx equal to F cos 45. We use cos because the theta are on the x-axis, and F equal to ma to calculate the acceleration. Last step, to solve it, you need to substitute the value into the formula. The final answer for the acceleration is 0.48 meter per second squared. For the next question, we will solve the simple question that relates to the normal force. Figure 3 shows a box with a mass of 3 kg is placed on an inclined plane with a smooth and frictionless surface at an angle of 25 degrees. Calculate the normal force. We need to identify the problem first. So, we need to find the normal force as stated in the question. But we need to do the resolution of force. And then, we highlight the information given where the angle is 25 degrees and the mass of the box is equal to 3 kg. And this question is a little bit tricky because we can find the normal force using the resolution of vertical component Fy. Now identify the suitable formula R equal to W cos 25 where W equal to mg. Lastly, after you substitute the answer, you will get the value of R. And don't forget to write the correct unit. So R equal to 26.67 Newton. That's all for our subtopic and I hope you guys enjoy this lesson. Thank you.